Hello everyone. We're showing how fAIr works in practice in this video. Uh, we're using here the development environment and we will try to create a demo by creating a training data set. That training data set will be using open aerial imagery link, which is here. And this open aerial imagery link is coming from OAM. For Kakuma mission flight that is deployed already in OAM. And we use the link from the TMS from here, and we added it in Open Aerial Map. Now, to create that training dataset, we need to define an area of interest. That area of interest needs to be a specific small area, 10 to 15%, 5% of the whole imagery. And we selected this small area. Now, after selecting the area, we can go and click here to fetch OSM data into this area of interest, and that will bring the labels, which are the annotation to create the training data set. We will repeat this process now by clearing all the area and then creating a much smaller training data set, which doesn't have any labels inside so far, because when we zoom in, we don't see them, but we can grab them from OAM. If the area is not mapped already in OSM, what we can do is we can press here and that will take us to ID editor in order to go and map that region manually. And then when the data is uploaded to OSM within a couple minutes, because we're using raw data API, would be able to come back and download those polygons. It took me around 30 minutes to an hour to create a training data set or to map like a small region like this one. And the data set is ready right now. What we can do next is viewing the models that are created using this training data set. And we already have a model created before. But if we don't, we can go ahead and create a new one and select the same data set that we created recently. This is a Kakuma model. We can go to its edit. This is a previous training for the model. I will submit a new training, but I will use the previous training because it takes some time to create a new model. The model specifications in general, the different zoom levels that we will need to use or download for the imageries when we create that model, the epochs and patch size. The epochs refers to the number of times we're training this model. And then the batch size is the amount of data we're feeding into the model in each time. Imagine the model to be a school child, and that school child needs to read a book, which is a training data set, for 20 times. And then whenever the child reads the book, each time they read 8 pages, 8 pages, 8 pages, 8 pages until the end of the book. That's one epoch. Then the next epoch will be 8 pages, 8 pages until the end of the book. The zoom level defines the different imagery. Here is the training data set. The zoom levels define those styles which we're feeding into the model, meaning now we are on zoom almost 18, and that zoom 18 has those styles. That's the image that we're feeding to the model. If we zoom to 19, those images are much higher quality. So those are the ones on zoom 19, which we're feeding the model. Then in zoom 20, those are the imagery we're feeding into the model. So if we go to the back, to the creating the model, those are the 3 levels we're providing to the training data set in order to create that model. This is somehow the same zoom levels a normal mapper would be mapping buildings. The same zoom levels when they log in when they zoom in. In order to create a new mapping, you will need to be able to see the model details. So we're assuming that around zoom 19, 20, 21 are the ones you need. If you go like zoom more than 21, that's like a very close, which is accurate, but it's enough until 22 because look at those small tiles. They almost have like one full building or one and a half full buildings. Going back to the training data set, we can submit the training and that training will be added to the queue. Because we're using currently a minimal specs, the training is active only for one model at a time, and logs are always available. This model is submitted for training and it already started training. We can watch the logs and see the model training progress for those 20 epochs and 8 batch size. Increasing the batch size will mean we'll need more power computing power. So far it works fine with the 8 batch size. If we increase it to 16, it might fail because we don't have the amount of memory required for 18 pages to be read in the same time. Currently, we're using a previous training. That previous training took around 42 minutes, and the training data size was around 252 because the training data set was bigger than the current one. The current one is around 189. So that's a previous training where we can go and publish it. Now, this training is published, and we can use this model for prediction. We're going to start mapping. It will load the same imagery. The training dataset we're focused on this area. We're gonna run the model in a different region. So we zoom into level 19, 20, or 21, and then the current view will be sent to the inference API, and upon running prediction, we will be getting the result. We can enhance the results always by using the quality, the queue functionality to make it like perfect square and change somehow the tolerance. The tolerance is the tolerance in geospatial terms. So the distance between two geopoints will be 0.3 meters, so it's around 30 centimeters. But if we increase it to 2 or 3 meters, we might be getting different results. I will run this model inference again into like same area and different areas. We're getting different results. And then if we zoom in here, we run the prediction. It's currently taking around like 10 seconds to run a singular prediction. But when we see like an accurate prediction like this one, we can accept it. Right click and then accept it. This one, if we think that a good quality for the prediction, we can accept it. If not, we can leave it. I accepted those two, but I think and I feel that those predictions are not accurate. So somehow we can feed back to the model creator saying the model is not predicting well in this scenario and the geometry will be over there. This one is not accurate. And if we have green buildings, we can open them with JSON, and then JSON will be open, and the buildings are changed into OSM data, and we can see them in the layer, in the data layer, and those can be pushed directly into OSM. We need to run a couple validations and download OSM data to make sure we don't have any overlap with OSM previous buildings. Those are already mapped, so we're getting an overlapped buildings. And then we can push easily into OSM using the normal JSON features. If we go back to the model's creation, this feedback can be viewed inside the model. So here is the model. We can view the feedback. In the feedback screen, we will see the original training data set where it was created, and then we will see the feedback by users. That's the feedback we got. That's the feedback we get from the users. Now we can somehow increase the quality of the model by defining a new training area, and that new training area can be downloaded and then used for fine-tuning the model again, and we can submit a new training. The freeze layer option is to add a new training uh, on the top of the previous training, meaning currently we're using the training 291. We can use that and then build on the top of it. So we're training the trained model again. We're fine-tuning the fine-tuned model again. Of course, those needs to be mapped already in OSM in order to grab them. If they are not, we can use this button as usual and then map manually. The area is already mapped manually. Well, that's why we can see the OSM data already there. If it's not, we will need like a couple minutes to hours in order to map manually and then come back here. It's also the model maintainer decision to see if this is the original data set, this is the new area, we can merge those two, and then in this scenario, we would go back to the original data set, and then we can create an area of interest here, and then we can retrain the model based on this area, those two area of interest from the beginning again. We can map them into OSM. If they are already mapped, it's even better. Then we can download the labels or the annotations. Those they are, and then we can go to the model and resubmit a new model training. That will take time. The previous one, which we submitted, took around 30 minutes. And for transparency, here are the models. This is a model checkpoint, and this is the model accuracy changes among the 20 epochs. The highest accuracy we got is around here, and this is the 97.3 accuracy we got. If we publish this uh, training, it will change here, and then we can use it for mapping again. During their training of the model, we have the logs available, what's going on in details, downloading the imagery, creating the labels, and then running the 20 epochs with 8 batch size. One by one, they will appear here with time. I think that's it. Uh, Looking forward to hear your feedback, and thank you for watching until here.